Welcome, everybody. So how's that for a question? Can a digital energy revolution save us from climate change disaster? Okay, that is quite a question, and we're going to try and dissect it somewhat. And I have three people here who are eminently qualified to talk about different aspects of that question. As a journalist, I often who's covered climate change for more than a decade. We often get accused of dwelling on the problems rather than the solutions. And mea culpa, I have to say, that is true. That is very much a big part of the reporting we do. In a way, I'm tempted to say it's even partially, at least, justified. Because until enough people take the problem seriously, until there's a kind of critical mass of opinion around the urgency of climate change, then it's going to be very difficult to move forward from there. Fortunately, as we've heard in the earlier session, perhaps, we've reached the beginning at least of that tipping point. I think we can all agree we've seen changes in the last 6 months that very few people anticipated would happen so quickly. Fortunately, there are a lot of people on this podium, and I'm sure in this audience, who have not waited for this point to start focusing on solutions. And so that's what we're going to look at today. So I'll introduce people gradually as we move through the conversation. I'd like to start with Brandon Owen, who is Director of Environment Strategy and Analytics for GE, a major global company in the energy sector. And Brandon, maybe you could help us set a kind of framework for this conversation. First of all, naively, as I began to read in for this session, I was asking myself the question, there have been digital elements to the energy system for decades now. So what is it that's actually new right now? And then the more important question, the follow-up question from that is, what kind of potential are we talking about in terms of making a difference? Because that's our overarching question here.
Okay, thanks, Marlowe, and thanks everyone for joining us. In terms of what's new, the industrial internet is a big piece of what's new. I mean, we think in terms of industrial systems and industrial technology, so large machines. They've had control systems since the 60s and 70s that optimize the operation of those, whether it's a power plant or an airplane or another piece of industrial equipment. But what's happened in the last decade is the emergence of what we call the industrial internet. And that's so it's much less expensive to connect all these machines back to the internet. It's less expensive to add sensors to monitor the machines, to monitor the output. And it's really kind of opened up a whole new world where we used to think about how to make a machine run smarter, more intelligently at the machine level. Now we're able to do that at the fleet level and also at the global network or global level across all these vast global networks, thanks to the industrial internet. So there is a new kind of element, and what that allows us to do is expand the scope of being smart about how we operate our machines. And when we do that more intelligently, that leads to environmental and economic benefits and reductions in carbon emissions. And so that's kind of the new piece of the puzzle.
So we're talking about artificial intelligence, machine learning, blockchain. Are these some of the elements?
Yeah, the advanced analytics is another important component of it, but we're getting smarter in how we make our software smarter. And so we're more sophisticated about how we approach optimization at the machine, the fleet, and the network level. So there's lots of, the evolution of information technologies and the improvement in the sophistication, but also the reduction in the cost have really kind of opened up a whole new world in terms of making our machines smarter and reducing the impact on the environment.
So you recently have written, I'm sure there were several of you on the team, but that you were the lead author on a substantial report kind of analyzing on a global scale the potential for these kinds of innovations in terms of energy grids, in particular electricity. Could you, what were your findings there? What kind of potential are we talking about?
Yeah, we've done a couple different studies. The the latest study is called the Digital Energy Transformation, where we looked kind of across the energy value chain and did some hypotheticals about scaling these technologies globally. So they're GE software that we're installing on mostly GE machines, but if you imagine we can expand that to all machines, all equipment, and have a reasonable level of penetration globally, the numbers start to add up pretty quickly. We have one solution called Digital Power Plant that makes our power plants operate more efficiently, saves 1% in efficiency per power plant. That doesn't sound like a lot, but if you were to scale that solution globally, just on the thermal power plants, that's gas and coal-fired generation, you could reduce emissions from the power sector by 10%. So it's a really big chunk just by adding a new element to the mix, which is smarter software. We used to do this with hardware gains. Now we've got a new tool, new digital tool.
Would it be accurate to say that essentially we're talking about optimization here?
Yeah, optimization, but now at a broader level across global networks. You can think of, it's not just power plants, it's airlines and aircraft. You're able to optimize routes now globally instead of at the individual unit level, and that's kind of what opens up all this potential.
Okay, so GE, a major corporation, your clients are the world's largest electricity grids, power companies.
Yep.
Okay.
Rail networks, airlines, there's GE Aviation, GE Transportation. On the power sector, we work across the power sector. We sell equipment, all kinds of equipment, wind turbines, gas turbines, steam turbines, and we offer software as part of those solutions. So
that grid, that power sector, serves most of humanity, about 6 billion people. But there are 1 billion people in the world who do not have access to electricity currently. And so while we're looking to optimize those existing grids, and there's a lot going on there, we simultaneously have to be looking for solutions for people who don't have any electricity at all. So I'd like to turn to Elizabeth Nyeko, who is the founder and CEO of Modularity Grid. And this is precisely the area that she is working in. Elizabeth, could you tell us a little bit how you approach this problem and what you're working on?
Yeah, great. Hi, well, thank you. Thanks everyone for joining us in this session. So when it comes to just electricity in general, I mean, the grid, as we've just heard, massive. In several countries have large grids. You can switch on the light, you know there's going to be electricity coming through, and the lights will go on. But for those who are completely off grid, the question is how are they going to be able to get electricity? And are they going to get electricity in the same way that we have electricity today? And the answer is actually no. We need to find sustainable ways of bringing electricity to those who are off grid. And our approach, I mean, our angle in particular is to simplify, to focus on a very, very specific kind of specific vertical within that challenge, which is the key barrier really to microgrids, which are small decentralized power systems. So small decentralized power generation and distribution system. So a network of homes, you connect them all up, and that's what you have. That's a microgrid essentially.
Typically, how big would a microgrid?
So it depends. So if there's a village with 100 homes, then you call it a microgrid because it's just they've got a number of power sources, typically solar, because that's what's the sort of cheapest source. You connect all those homes up, you put solar, you put a battery, and then that's essentially a microgrid. Now, the problem with these microgrids, I mean, yeah, they sound great. Why don't you just have several of these microgrids everywhere would be the next question, you know, if they're so great. Then the problem really is that they're super expensive to set up. And when you set up one microgrid, you've set up one microgrid. When you've seen one microgrid, you've seen one microgrid. You can't just replicate the exact same designs in lots of different locations. You always have to go through a design process, an installation process, and then a scaling process, which means that if more houses are added or people's consumption goes up, all of that requires incredibly high levels of expertise in order to be able to handle. And it's a very expensive process and a very lengthy process, and and you have to repeat that every single time you're setting up a new microgrid. And that brings up the costs that you have to spend. And in the end, if you're talking about a low-income community, when will they ever be able to pay back the cost that it took to actually set up that microgrid? And so this really disincentivizes people who are coming in to invest in this sort of sector. So the problem that we're tackling is essentially this issue of the scarcity and cost of expertise. And our angle is to use software to make a microgrid modular. And what does that mean? It's really about allowing a non-expert user to be able to assemble modular components, just like Lego, and be able to end up with a microgrid that operates. So simplifying the assembly and then the modification of that network thereafter, being able to add additional components. And to achieve that, we're using a combination of machine learning, control, and optimization to be able to have a flexible network that can accommodate any potential combination of components and still be able to run in a reliable manner. Yeah, so that's us.
One thing that struck my or caught my eye in looking at or when we spoke before about your project was the fact that you have a pilot project in Uganda in a village. Yeah. Is that correct? That runs primarily on biomass or a mix of biomass and solar. Why did you make that choice, and is that something that can be extended or scaled to other?
Yeah, so essentially, because our innovation is in the sort of the embedded software, and so we interact with existing hardware, existing power sources, existing solutions. So we thought, okay, wow, well, if we have this opportunity off-grid to create the new way that energy can be distributed to people and generated and distributed, why don't we push the boat out? So if you have a solution where you have solar and batteries, you have to think about the battery. What type of battery is it? What sort of mining and how sustainable is that battery at the end of the day? And can you really scale that solution without impacting? So then we thought, what about another combination to be able to still achieve that same level of reliability? What's a different component that we can use? And we thought biomass is a great source. So biomass is really just we were using any sort of plant-based product, like waste products. So in particular, this pilot uses waste from agricultural processing. And if you can use that as a source of baseload power, it essentially acts as a proxy storage. You don't really need storage in that case because that can run at any point in time, and then storage is simply a bunch of leaves that are compacted and sat in a store rather than a battery. And then you add solar on top of that to handle the peaks. And then that's where the software comes in to be able to manage all of that, the operation of all of that, and also the assembly bit, just simplifying the assembly so anybody can do it. A robot, we were saying either a robot or a non-expert user being able to set up a microgrid.
Thank you. We're going to come back to you, Elizabeth, in a few minutes because I do have a follow-up question on that. But first, I want to bring Nils Joyeux into the conversation. Nils is the founder of Zéphyr and Borée, which is a company, and he will explain to you what that's about. I have to say personally, just a little personal note here, as someone who's dwelled so much on the problem, it's really a breath of fresh air to come to a conference like this and see innovation, ideas, energy around these solutions. And one of the things that strikes me with all of our panelists, and Nils you'll see why shortly, is this ability to think outside the box. And so Nils has a very interesting project he's going to tell you about, which is in some ways old wine in a new bottle, or new wine in an old bottle. I'm not sure which.
Hello, everyone. So at Zéphyr Borée, we are trying to develop a low-carbon sailing company, shipping company. So I am a merchant navy officer, former merchant navy officer, and we started to work 4 years ago on the way to reduce the fuel consumption of shipping of cargo ships, and to reduce the carbon emission of the shipping. And what is funny is that it appears that the best way to tackle the CO2 emission is to use the wind again. The wind that we abandoned 100 years ago for the engine, and today we are more and more to think that if we want to tackle in a great way the CO2 emissions of the shipping industry, we have to use the wind again, but in industrial way with a modern kind of sails. So some people are working on big kites. Some other are working on turbo sails. On our part, we are working on wing sails. It is a kind of wing of a plane, but on a ship, and it is completely automated. And also today, with nowadays technologies, we are able to know by advance, before to build the ship, what kind of savings we can get with the wind. So, for example, right now we are working on a project between Norway and Spain, and we are running a routing software allowing us to know what savings we will be able to get in March, in April, in August, depending on the meteorological statistics and the provisional performances of the ship. And so it allows us to reduce by 30-40% the fuel consumption of ships. And you have to know that on that kind of ship, we burn something like 40 to 50 tons a day of heavy fuel oil. So it's a massive savings.
So just by way of context, the shipping sector currently accounts for about 1 billion tons per year of CO2 emissions. That's 2.5–3% of the global total. If you look at projections for the growth of that sector, it's projected to at least double, possibly triple by the middle of the century. And it's also a sector which somehow slipped under the radar during the negotiations that led up to COP21 in Paris. So in other words, it's not part of the agreement, and therefore, for the moment, is just self-policed. So the stakes, in fact, are very high here. Which brings me to kind of a second round of questioning, which is bottom line. How much can we gain here? How much of a difference can these technologies make at scale? Before we get there, though, another wonderful example of the kind of out-of-the-box thinking that I was talking about. Elizabeth, please explain to us why you have a contract with Airbus.
Yeah, so essentially what our platform is doing is simplifying the design, installation, and scaling of a power system, of a standalone power system, a standalone DC power system. So a power system could be on Earth or it could be in space. And so we thought, wow, well, what is going on in aerospace and what opportunities in aerospace can we use to this solution to tackle? And then we thought, actually, satellites are quite an interesting predicament. Today's satellites are actually, you build it, it has a single mission, it'll do one thing and one mission only over 15 years. And The thing is, at the end of that 15 years, you leave it there and then you get a new satellite. But now we've got to a point where market needs are changing so quickly that you can't replace your satellites every 15 years. You need to replace them every 5 years. And so you're leaving that thing there, you're sending another one to then do this new mission. And so people are going, oh, how do we make this more cost effective? Well, maybe just make them smaller, and you send lots and lots of them up and just leave them there and then just replace them, and it becomes much cheaper. And so we thought, wow, well, this is a nice little segue for us, because if you simplify the design and installation and scaling of a small standalone power system, you can essentially use that in a satellite, because then suddenly it makes your satellite versatile. Because instead of just leaving the satellite there, you can add an additional component. Suddenly, so a component that could be an additional solar array, an additional battery, an additional payload, which is specifically what the satellite controls, what the satellite does. And this is exactly actually what we're doing on the ground, but just changing it to the satellite context. And suddenly you've got a versatile satellite that can last twice as long, even 3 times as long, depending on how you physically add these additional components. So that's one side of the things. But then even before that, if we step back a bit, even before you've sent the satellite to space, simplifying and speeding up. So it takes about 5 years for a large telecom satellite to be sort of designed, and assembled, and that stage can take between 1 to 5 years. And if we bring that time period down, it saves a huge amount of cost for the satellite industry. So we're using essentially our existing platform to address this challenge for the satellite space, and we've got a contract with Airbus to do a proof of concept, which we've been running through at the moment. And yeah, we think it could be an exciting way to change how such satellites make them more sustainable.
Curious, Elizabeth, did you just go and knock on the door and say, I've got an idea? I mean, how did you make that connection with Airbus?
So I went through a competition process. So they were out there saying, do people have interesting ideas? What are you working on at the moment? And I went in, I talked about off-grid rural electrification in Africa, and they were like, what? And I said, well, there's something that we have in common with satellites, and it's this. And then they thought, oh yeah, good point. So yeah, that's how it happened. And I got to spend a number of months.
And correct me if I'm wrong, but as I recall in our conversation by phone, you thought that, in fact, the satellite project is probably a good bit easier than the one that you're doing on the ground. Is that correct?
Yeah. It's
Why is that?
So in the context of a satellite, you're looking at well-defined power consumption. It's been planned 5 years, 15 years in advance, exactly what the satellite is going to do. No surprises on that front. Whereas in a rural off-grid community, you're looking at really small, sporadic consumption patterns that are really difficult to predict, and which end up actually behaving like active power loads, which becomes really difficult to actually control and manage. So solving the problem in a satellite is so much easier than getting the product certified and then repurposing it for our ground use. Ends up being a nice round-the-way approach.
Thank you. So coming back to our 40 billion ton question, that's the amount of carbon that CO2 that we put into the atmosphere every year. And coming back to our question here, how much of a difference can this make? Nils, do you have any kind of ballpark idea that if your idea works out and can be scaled up, you mentioned 30-40% energy gains. If you scale that across a significant portion of the shipping sector, what kind of difference could it make?
It's a complicated question because I truly believe that the energetic transition cannot make the job on its own. So as I told you, with the sales, you can save up to 30-40% of the fuel consumption. This is cool. We will try to show this technology to other shipping companies to scale up as fast as possible. But we also need to reduce the speed of the ships, of the global fleet. This is one of the best way to reduce the fuel consumption. And also, I think we have to divide by 5 the global fleet, in the world. And after the 5th, we have to put sails on it. But we cannot just rely on Internet of Things or on sails on cargos or on smart grids to meet this huge challenge.
Do you have a prototype? Is that correct?
Yes,
ship?
correct. Yes.
And what are your plans in terms of building one to scale?
We just signed it with a major industrial actor. I cannot tell you today who is it, but it will be revealed in a few weeks. And so it's a new building, because on other project we plan to install the sails on existing ships. But for this project, it's a new building because it's a quite particular ship for a quite particular market. And so it is 121 meters long vessel, and we will start the building beginning of 2020, and we will launch it end of 2021. So in 2 years, there will be a first modern cargo ship.
Okay. Are there any journalists in the room reporting on this? Okay, good. Just in the sense that it's a really good story. Keep your eye out for it. I know a little bit more about it. Well, let's come back to this question then. And Brandon, you've actually crunched some numbers on this in terms of the potential for the kinds of optimization that we've been talking about. What do they tell you?
We did a study with Intel. It's called Digital Efficiency. You can find it on the internet. Just search Digital Efficiency, GE Intel, where we looked at all of these solutions, transportation sector solutions, lighting solutions, power solutions, and sort of added up all the numbers. If it's scaled globally, the number that I have in my head with me today is on the power side. We looked at grid solutions, grid automation, smart grid. Those technologies are more efficient in how they transmit power. They enable power to be transmitted more efficiency. They reduce power generation and power consumption. If you were to scale just that one set of technologies globally, the number we came up with is 2 billion metric tons or 2 gigatons by 2030, just for that one software solution in the power sector. So as we stack these together, we end up with some pretty substantial numbers. I think that is 5% of the global total right now. I wouldn't say that we think that digital is the only solution or digital is going to save us. I think digital, we've got a new tool in the toolkit, and we need to think seriously about how digital technologies can be brought to bear to help address the climate challenge.
Based on our conversations, my impression is that despite what would seem to be obvious advantages, your clients, sort of large companies, power systems, are not necessarily jumping at the opportunity to add on these kinds of technologies. What's the problem there potentially?
Well, it's new technology, and so there's a risk. Any business enterprise is not going to want to change things from the way they've always done things, and there's an upfront capital expense associated with it and uncertain gains because it's early days. And so we've had some challenges in deployment. We think those challenges are going to ease as time goes on. One of the things that we would like to see is more of a level playing field. Policymakers have traditionally focused on hardware gains, efficiency through improvements in hardware, whatever that hardware is. And they have provided incentives, grants, and things like that on the hardware side, and we haven't seen as much on the software side. So some more incentives to incentivize these early adopters and get more adoption so we can learn and really scale globally.
So would you need to see changes in the policy environment in order to accelerate that process? Is that something that companies are looking for?
That would be a change in the policy environment, or at least, as again, I said, a level of leveling the playing field, not necessarily.
What does that mean, for example? Give me an example.
It means providing the same sort of tax incentives, for example, that you have for wind or solar power for the digital component as well. and recognize this is a new tool and a new option to achieve the same objectives.
So everybody has subsidies except software.
Software is just underrepresented because it's a newer option, and we haven't thought about software as a means to meet climate objectives for very long. And so, there needs to be some readjustment in our thinking, but if we can achieve that, then there's massive potential, which I've outlined. So it's pretty exciting.
Okay. Well, I think that gives all of us a kind of good idea of what these people are working on, and I'm happy to end things here in terms of this part of the process to open up the floor to questions. I hope you have some. Yes. If you would be so good as to identify yourself.
Yes, hello. Thank you very much, everyone. My name is Sophie Lam from Kite Insight. Marlowe, you start the conversation by conceding to the responsibility of the media of maybe have not profiled the issues around solutions. I'm just interested to hear from our panelists. We're talking about change, climate change, disaster. We have little time to go. What might be your expectations from the media and the role that they can play in supporting your objective in scaling up your solutions?
We would like to see some more balanced coverage on the digital aspect, highlighting some of the case studies, some of the solutions. We at GE have been trying to connect the dots. We've written several reports about it. We have this concept we call digital sustainability. We'd like some more focus on that, some recognition that, again, as I said, we've got a new tool in our toolkit to fight the climate war. Well, more balance, more coverage on the digital side, which would balance the coverage in total.
Yeah. Then I would say also just recognizing perhaps that different, it's the same problem everywhere, but different locations sometimes need very different solutions. So what would make a microgrid work in the US is probably not the same solution that would kind of work in a different setting, and it's just kind of highlighting the different versions of the different solutions that are out there, the different innovations and kind of the different business models that people are using, and just making, I guess the big challenge is a lot of policy makers are perhaps not aware of the potential for smaller businesses to also come up with solutions, and so creating for them that environment to be able to do what they're doing, to be able to develop their technologies. So I say, so because governments aren't aware of that, they end up not really looking at that. And then that ties into, for example, availability of grants for sort of high risk technology innovation. A lot of grants that are targeting energy access in particular are all tied to using commercially proven technologies that are developed in certain specific countries. So then it limits the types of solutions that you end up seeing to energy access and to clean energy. And so it's difficult for policymakers to turn around and say, oh, but we want to do something different, or whoever's designing these grant calls to turn around and say we're doing something different if they don't know what's perhaps out there.
So then the media might have a role in highlighting some of those, yeah.
Marlowe, there's one more thing I want to mention that I forgot, which is there's a lot of misinformation out there on digital technologies and the footprint of data centers. Most of the coverage around digital seems to be focused on the environmental footprint on the data center side. So as we expand our digital footprint, that's a bad thing for the environment, with no coverage on the potential benefits that I've just outlined. There are several studies, not GE studies, out there that show that potential benefit is an order of magnitude 10x the increase in greenhouse gas emissions you get from increasing the number of data centers. So again, more balance on the benefits, and rather than just a focus on the environmental cost.
Thank Thank you. Jürgen Hecker, Senior Economics Editor at AFP. I would like you to stick your necks out a little bit and throw parts of the question of the panel back at you. A revolution, that's a big word. Are you persuaded, convinced, and can you convince us that we're talking about a revolution here and not just evolution? And can, if so, this really save us from climate change disaster, which is barreling down the road at us at dizzying speed? And is that going to be enough? Or is it just one tool in the toolbox, as one of your panelists said?
Sure. Okay. Yeah. So I have an interesting kind of angle on that, because lack of energy access in such a huge proportion of the world, while it is a problem, it's also a really interesting opportunity to test bed some really exciting new ways of doing things. And so going forward, for example, we're already seeing a lot of people having in the developed world, having solar in their homes and wanting to go off grid. And so in future, are we going to see grid defection and people going off grid? And as people do that, what are some of the models that we can learn from in an off-grid setting of these decentralized standalone power system? What types of business models? So one particular type of business model that we've been looking at with another company that we're partnering, a developer, is saying, okay, do you know what? Can electricity distribution look beyond selling electricity as a source of revenues? Ryanair would be a classic example. You have sort of €5 tickets taking you from Toulouse to Edinburgh because they're making their revenues off of advertising, off of other things. And because fundamentally electricity and energy poverty is not only an issue for people who are off-grid, it's also an issue in the UK for low-income families who are struggling and spending a huge proportion of their monthly earnings on paying their electricity bills. And so the question then comes around to, can energy companies think differently, use new business models that are being used and developed in these off-grid places to inspire them to develop new solutions and new approaches? So using that approach, we could actually end up with a real revolution, perhaps.
Thanks. It's maybe an incremental revolution, if I could cheat. I think the industrial internet is a revolution. I think the ability or the Internet of Things, the ability to connect millions of devices to the internet, we can do that because we're leveraging the internet that already existed, but also because of the improvements in computing power, the reductions in cost. It's opened up this world of possibilities. That's revolutionary. We can then use that, leverage that to improve the environment through these energy applications. The one thing I would say is that we don't keep coming back to this sort of toolkit analogy. Digital is another option for us. I don't think that we're short on options for addressing climate change. I think the solutions, the technology is available. I think what the world is short on is implementation. That has a lot to do with political will, has a lot to do with market regulatory frameworks, incentives, things like that. But we've brought a new option to the table, and depending on how the markets get structured, how the policies get written, that technology can be deployed to fight climate change.
Other questions?
Yeah.
Yes.
Yeah. We did not speak a lot about the citizen, and I think one of the targets will be reached by the behavior. It's a big matter of behavior, not only companies or politicians. And an economist called Carl Susskind wrote about nudge theory. Did you heard about it? The nudge theory is the incitation policy where you provide many figures to the citizen so that they see if they are in the average consumption, for example, for electricity, and that they will move to the, an ideal behavior, so then they lower the consumption. It would be especially good for the wealthy country rather than Africa, which need to have electricity now to have the modernity. But for like in France and America, we consume much more electricity than we should do. Though you heard about it, the smart grid in California, for example.
I haven't heard about that theory, but you're talking about data transparency, basically reducing the cost of acquiring information.
Provide data to the consumer so
Yeah.
he can see his own consumption compared to the average consumption of the same profile of family and so on.
Yeah, I've seen that, and I've seen there's third-party providers that help utilities send information to their customers that say, you know, here's what you're consuming, here's what your neighbors are consuming, here's the average, and you sort of guilt people into oh my God, you know, I'm doing 2 times my neighbor, so I need to shape up. But this whole idea, and it relates to the internet, but this whole idea of providing, reducing the barriers to acquiring information or the cost of acquiring information or creating a more transparent system, I think does facilitate that movement towards decarbonization.
We had one more question up here, I believe.
Any other question?
Hi, I'm Sophie Lam, also from Kite Insights. I'm aware that this question has already been partly answered. Just going back to the wording of the question again, which for me evokes this kind of cliff edge image, the words save us and disaster.
You guys wrote the question.
True. I suppose my question was, do you believe that digital energy, that the digital energy revolution is the thing that can save us? Is it the thing that can save us, or is there something else?
Okay, it is complicated with my poor English, but no, I truly think that it will not save us from the disaster. I don't know if you already heard about the rebound effect, but for example, on the internet, I guess you remember 15 years ago, you had your how do you say, your hard disk. It was big like this, and you have to plug it, and it consumes some energy, and you had only maybe 10 or 20 gigas inside, and now in something big like this, you can have 1 teraoctet on it, and it consumes nothing. So we are thinking, okay, great, it consumes less energy, and we are getting optimizing everything. And in fact, today, what is the result? We have autonomous cars creating 3 teraoctets per day. When they are moving and running huge data centers. So in fact, as soon as you optimize something and you get it cheaper and more effective, we are consuming it way more. I don't know if I'm clear, but for example, if you compare to nowadays cars and the cars from 40 years ago, okay, nice. The engine is way more effective, but in fact, the cars is 2 times heavier and plenty of how do you say, climatization and etc.
Air conditioning. In other words, we don't take advantage. We don't take advantage of the gains.
The answer is in the behavior and not in the technologies. I'm sure of that, because I will just finish, but I think it's important to stop believing in the energetic transition, because to succeed the energetic transition would mean that we manage to disconnect the curve of the PIB and the how do you say it in English?
GDP.
Yes, and the curve of the CO2 emission of the world. And in fact, we did not manage to disconnect even at least we did not manage to disconnect these 2 curves. So we must stop to believe that this is the solution, because otherwise we will wait too long time before to take the true solutions.
Okay. Well, thank you very much. Just a closing anecdote rather, not a comment. I recall a conversation I had with a climate scientist who we were talking about different solutions, different components of what might might save us. And at one point, I remember asking him, "So on this particular point, you think we need a silver bullet?" And he said, "No, we need a hail of silver bullets." So that's kind of where we are now. We need everything, many things, to work at once together optimally. Thank you very much.